So we are dealing with the 10th problem in this series, and the 10th problem in this series is problem number 1.327. The problem is stating the side wall of a wide vertical cylindrical vessel of height 75 cm has a narrow vertical slit running all the way down to the bottom of the vessel. The length of the slit is L equals 50 cm and the width being 1.0 mm. With the slit closed, the vessel is filled with water. Find the resultant force of reaction of the water flowing out of the vessel immediately after the slit is opened. So this is a very interesting problem, and the first thing that you need to understand is what exactly the problem is talking about. So in order to understand this, we will draw a diagrammatic representation of the situation. So this is how we can explain the situation which is given in the problem. The slit in the problem is this part, so we are able to see from the side view this slit as this big opening, but it must be kept in mind that it is not that wide. The width is just 1 mm. Now the problem is because of the difference in vertical level of the fluid is different at different points on the slit, the velocity of flow will also be different. So if at a distance x from the surface, we select a point, then this point will have a flow velocity v being equal to root over 2gx. And if we select a patch of thickness dx over here, over this entire length, then this dx will mean only this much on this surface. So at the distance x over here can be marked on this slit as this way, and then we have a width dx. So area patch over here is b dx. So now if we calculate the force equation can be written as dF equals rho dA v square. So this is the expression for force which we have derived in the earlier problem also, and it is also a standard result in many texts. So over here if we write dF, so dF equals rho, dA equals b dx, and v square can be written as 2gx. So if we integrate this result, we get 2 rho bgx dx, and the integral runs from L minus h to h. So L minus h to h, so this height is technically L minus h, and it runs all the way down till h. So L minus h to h, and we get the final answer as rho gbl 2h minus L. So this is the answer for the force for this particular problem, and if we substitute the values that is given to us, we get this value of force as 5 Newton. So this is how we understand this particular problem, where the problem is discussing about the discharge through a volume or discharge of fluid through a particular area which is small. The slit is a very small hole which is made in this, but the length of the hole is too large, so the velocity of flow will be different at different points. So this was problem number 1.327.